Hello everyone, welcome to my channel One Concept W. This is one of DC machine question. Mainly, this concept in this particular question is speed control of DC machine. Before solving this question, let's know what the data they are given. Here it is given a DC shunt motor. Takes an armature current of 50 amps at rated voltage of 240 volts, means terminal voltage of 240 volts, and armature resistance of 0.2 ohm. And the given external resistance is inserted in the circuit of 1 ohm, means 1 ohm is added into the armature circuit, and they given the free flux is unchanged, means flux is constant. And they are asking, if load torque is constant, what is the change in speed? Will it increase or decrease? In the second question, they are asking, if load torque is half its load, half of its full load, then speed will increase or decrease. They are asking for partially increase or decrease in speed. Let's write down the data. Here is given armature current of 50 amps and terminal voltage of 240 volts, an armature resistance of 0.2 ohm, and external resistance is 1 ohm, and flux remains unchanged. Here I am finding the back EMF of a motor without adding an external resistance. Without adding an external resistance, the back EMF is EB equal to Vt minus IARA. Then the back EMF is 230 volts. Now, if external resistance added into the circuit, means I am adding 1 ohm in series with armature circuit. Now, in the case one, they are using at the same load torque, means torque is constant. Means torque is constant. Torque formula is K into phi into Ia. Here K is in constant, flux is constant. They already given the flux remains unchanged, means flux is constant. Means T is proportional to Ia. If T is constant, Ia is also constant. Means Ia1 equal to Ia2. Ia1 is here 50 amps. Without adding external resistance, the armature current is 50 amps. After adding external resistance also, the armature current is 50 amps only by this equation. Now the back EMF under this condition means at the rate torque is constant, at the rate flux is constant, armature resistance R external of 1 ohm is added, then the armature current is 50 amps. By using this equation, I am finding back EMF EB equal to Vt minus Ia into Ra plus R external. By this, the back EMF is 180 volts. We already know the back EMF formula EB equal to K into phi into omega. Here, EB1, back EMF of a DC shunt motor without adding an external resistance. EB2, back EMF of a motor by adding an external resistance of 1 ohm. In both the cases, flux is constant. N1, the speed of the motor without any external resistance. The speed of the motor they given without an external resistance is okay. The N1 data is not available. By substituting EB1 and EB2, I found an N2 by N1 is 0.782. Here they are asking partially increase and decrease. Means we need to find N2 minus N1 by 100. N2 minus N1 by 100. Here it is minus 21.739. Means by adding an external resistance of 1 ohm, and torque is kept constant, then your speed will reduce by a percentage of 21.73%. Here you see in the second condition they are given the load torque is half of its full load torque, means T3 equal to T1 by 2. We already know torque equal to K into phi into Ia, flux is constant, K is constant. By substituting in this formula, IA3 equal to IA1 by 2. IA1 is 50 amps. Means in this condition the armature current will be 25 amps. By this EB3, the back EMF of a DC shunt motor is 210 volts. Here phi1 equal to phi3 because flux is always kept constant. EB1 by EB3. EB1 is the back EMF of a motor under rated condition. EB3 back EMF of a motor after adding an external resistance of 1 ohm and load torque is half of its full load torque. N1 is speed of the motor under full load. N3 the speed of a motor when external resistance added and load torque is half of its full load torque. By this I am found N3 by N1 equal to 0.913. Percentage reduction, percentage increase or decrease is N3 minus N1 by N1 into 100 is minus 8.6%. Means if your load is half of its load torque and external resistance of 1 ohm is added, your speed will reduce by 8%. Speed will reduce by 8%. In the both the cases, there will be decrease in speed by adding an external resistance and load torque is varied. Then in the both the cases, there will be decrease in speed. This is a very good question on speed control of DC shunt motor. For this sort of question, please subscribe to my channel.